new gel technology could form a new type of treatment to help hearts regenerate after injury. University of Manchester researchers have developed a new biodegradable gel that can help to improve the delivery of cells directly into the living heart and could form a new generation of treatments to repair damage caused by a heart attack. Scientists have been looking for ways to introduce new cells into damaged hearts for years as a way to repair it and reduce the risk of progression to heart failure. But historically, when cells have been injected directly into the heart, only 1% have remained in place and survived. Now, researchers from the University of Manchester have developed a new biodegradable gel that can be safely injected into the beating heart to act as a scaffold for cells to grow new tissue. The researchers hope their gel will become a key part of future regenerative treatments for damaged hearts. The researchers said this gel will be an effective option for future cell-based therapies to help the damaged heart to regenerate. For any successful treatment, a good blood supply will be vital for the injected cells to develop into new tissue. The researchers saw early signs of blood vessel growth into the gel, proving the technology could boost growth of new vessels. They also showed that the gel can support growth of normal heart muscle tissue. When they added human cells that had been reprogrammed to become heart muscle cells into the gel, they were able to grow them in a dish for 3 weeks and the cells started to spontaneously beat. In order to prove that this technology could work in a living heart, the team injected the gel with a fluorescent tag into the hearts of healthy mice. The fluorescent tag revealed that the gel remained in the heart for 2 weeks. Echocardiograms, that is ultrasounds of the heart, and the electrocardiograms, ECGs, which measure the electrical activity of the heart, confirmed that the injection is safe for the heart. The researchers now plan to trial this treatment in mice straight after a heart attack to see whether the heart cells can develop new muscle tissue and help restore the heart's ability to pump efficiently. The gel is made of chains of amino acids called peptides, the building blocks of proteins. The bonds between the peptides mean that the gel can exist in different states. When it is under stress, the peptides disassemble and behave like a liquid, making it ideal for injecting. When the stress is removed, the peptides reassemble almost immediately and behave like a solid, holding the cells in place as they graft onto the heart.